Be just a quick little lecture about ABO blood groups because there isn't much information in your study guide. So general blood typing is done based on the fact that there are some glycoproteins that are found on the surface of our cells. Genetically, they exhibit what's called codominance, so that we have an allele for an A glycoprotein, as you can see depicted by the little spiky things on the surface of the red blood cell. And then we have another allele, which is expresses the B glycoprotein, which is the little circles on the surface of the red blood cell. And then and both of those are dominant, and if you get both recessive alleles for blood typing, then you'll be like type O blood, where you don't have any antigens on the surface of your red blood cells. So what that does genetically is give us the opportunity to have no surface antigens of the ABO type. There are other antigens on the surface, but the most problematic for rejection or transplant mismatch or transfusion mismatch is the ABO group that Landsteiner came up with back in the 40s, I believe. And so you can be type A with the A antigens on the surface, you can be type B with the B antigens on the surface, or you can be type AB because it's codominance. Both the A and the B alleles will be equally expressed, and so you will have just as many pokey things as you'll have little circles on the surface of your red blood cells. Now, in addition to this, we have another antigen called the RH factor, which is a protein that is either present or it's not present on the surface of the red blood cells. So instead of just having 4 blood types, it gives us 8 blood types. So you can be O positive, which means you would possess the RH factor. You could be O negative, which would then mean you don't have the RH factor, and then A positive, A negative, B positive, B negative, AB positive, AB negative. Okay, so as you can see in this picture, that if you express a particular antigen, you will produce the opposite antibody. And so you can see, let's take type A, for example. So a type A person is going to express A antigens on the surface, but then they are going to produce B antibodies. So it's anti-B. So these are antibodies against B. And if you'll notice, their shape, what they would bind to, is circular. If you look at this type B person, they have anti-A antibodies. And so you can see, oh yeah, those would stick and bind to the structure of the A antigens. The mechanism for being inoculated with the opposite blood type is not entirely known. They are glycoproteins as opposed to just regular proteins. So they are carbohydrates that we find on the surface of our cells and may be absorbed postnatally in our food or whatever. And somehow we become exposed to these antigens and then make antibodies against the ABO antibodies. So we already have the antibodies in our systems. If we were to receive the wrong blood type, then we would start, the antibodies would bind to the antigens and then cause an agglutination reaction, which we'll talk about later, and that would result in the destruction of the transplanted red blood cells. You can notice in an AB person, because they express both antigens, that they have neither one of the antibodies. And the type O people, because they have no antigens on the surface, are going to produce both antibodies. Okay, so I kind of went through what would happen if you receive the wrong blood type. The rhesus factor influences blood type. I got that. So the blood type that is known as the universal donor would be a blood type that has no antigens on the surface whatsoever. So that would be an individual who is O negative. So not only would they not have the A antibodies, the A antigens or the B antigens, but they don't have the RH factor either, or like it says, the D antigen or the rhesus factor. And so anyone can receive O negative blood because there are no antibodies against O negative blood. The universal recipient, on the other hand, is somebody that has all of the antigens present because they don't make any antibodies at all. So an AB positive person is the universal recipient, and they can receive all blood types because they don't make any of the antibodies at all. Okay, so if you go to your study guide and what blood types would cause a transfusion reaction, then if you are A positive, you would then have antibodies against B. So any of the Bs would cause you to produce a transfusion reaction. Not any of the positives though, because positive people don't make Rh factor antigens. A negative, on the other hand, would any of the Bs would cause a transfusion reaction, including O positive, because a negative person would produce antibodies against the positive antigen. However, prior exposure to that rhesus factor is required in order to produce antibodies. We don't naturally have Rh factor antibodies circulating in us. Even if we are of a negative blood type, we have to be exposed to that. And so that's where we get into the hemolytic disease of the newborn. So what happens in this case, and hemolytic disease of the newborn will only happen in infants who are born to an Rh negative mother. So you girls out there that are A negative or O negative or AB negative or B negative, you are going to have to be aware of this, and your pediatrician or your obstetrician will take care of this when you become pregnant. But this is why it's important to have prenatal care, because we do not want a baby that is Rh positive born to an Rh negative mother without having a RhoGAM shot, and I'll explain why. So here's the deal. So an Rh negative woman means that she has the potential to make antibodies against the Rh factor if she is ever exposed to the Rh factor. Well, when she's pregnant, in her first pregnancy, she is not exposed to the baby blood. The membranes of the trophoblast and the fetal portion of the placenta prevent maternal blood and fetal blood from ever mixing until birth. And then when the placenta comes away from the endometrium, from the lining of the uterus, that's when maternal and fetal blood can mix. So if an Rh negative mother has a baby that is Rh positive, at the time of birth, those Rh positive antigens on the baby's red blood cells will then enter her body, and the woman will then set up an immune reaction to that. And the bad thing is that she will produce antibodies against that, and she will produce memory cells. And so that will forever inoculate her to Rh positive, the presence of the Rh factor. The first baby will be born just fine, no problems, and it's the subsequent children that will become affected. And so let's say she gets pregnant again, and because the father of the baby is Rh positive and he passes that Rh positive factor on to his offspring, now we have Rh factor floating around in that placental blood. That's, the fetal portion of the placenta, and the antibodies that are produced, IgG antibodies, can easily cross the placenta. So now she's got Rh factor antibodies that are going to cross the placenta and now attack the red blood cells of the fetus, and thereby killing her baby and every other baby that happens to be Rh positive. And when we talk about this in my on-campus classes in Arizona, we often think about people pioneer age 150 years ago, even maybe just 100 years ago, and where the first child was born and then every baby after that died, and that was probably because the mother was Rh negative and the father was Rh positive. So how do we prevent the subsequent babies from getting hemolytic disease of the newborn? Well, we give the mothers what's called a RhoGAM shot. Now, when we shoot people with things for immunity, we can do two things. We can give them the antigen like we do in a vaccination, and that's known as artificially acquired active immunity, where we inoculate you with the antigen and then we cause your body to produce memory cells and antibodies against it, like with measles. So please vaccinate. But we don't want that in this particular case. What we want to do is give the mom some preformed antibodies against the Rh factor so that her body never sees the Rh factor and that it is effectively eliminated by the antibodies that she received in what we call an artificially acquired passive immunity. So the RhoGAM shot, so it's rhesus gamma globulin is what RhoGAM stands for, is a shot of antibodies that the woman will receive during her pregnancy. It used to be just 72 hours before birth, but now we do it routinely through the pregnancy, sometimes 3 times. And so these antibodies are traveling now through the mom in the event that she has an Rh positive baby and that the Rh positive blood of the infant or the fetus gets into her bloodstream, that blood will then be targeted for destruction. Agglutination will happen and macrophages will come and eat it up from within the mom's body. So we don't have to worry about the subsequent babies suffering from this disease. So there you go. That was blood typing. I don't think there's anything else. Let me just tell you really quickly how we would see on like a blood typing slide. If you had a particular blood type, we would take your blood and then we would add A antibodies and then B antibodies in a separate well and D antibodies, and whenever we had what's called an agglutination reaction, then we know that that's the blood type you have. And the reason why they agglutinate is because the sera that we use has IgM antibodies in it that form what's called a pentamer. So 5 antibodies hooked together, and the arms of an antibody looks like a Y, in case you weren't aware of that. And so antigens on the antibody or on the red blood cells will bind to the arms, so we can clump together a group of at least 10 red blood cells with one IgM antibody, well, a pentamer of IgM antibodies. And that agglutination reaction then makes it easier for the macrophages to come and eat it up. So that's how we identify when we're blood typing an individual. And so that's what will happen if you have hemolytic disease of the newborn, is you'll get that agglutination reaction happening within the baby's body, or you'll have lysis. And if we have hemolysis happening, the same antibodies are going to bind to the baby's red blood cell and trigger an immune response called complement. And the complement proteins are going to come and sit down on the surface of the red blood cells and cause what's called a membrane attack complex, which pokes holes in the membrane and causes it to lyse, and then the red blood cells, of course, go through lysis. So that's I think that's everything that you need to know about blood. Well, blood typing anyway.